Alright, in this video we're getting into Chapter 6, there'll be another video coming shortly that'll do some more with logs and exponentials. And this one here we're going to be looking at graphing logarithms and exponentials. Now earlier in the semester we did do some graphing, some exponentials. So a little bit of a recap here. Exponential function looks like f of x equals b to the x power, where your base is greater than 0 and your base is not 1. The exponent is x and can be any real number, so your domain is going to be all real numbers. The horizontal asymptote is going to be y equals 0. Domain again is all real numbers. Your range is going to be 0 to infinity in stock form. If you have some sort of transformation, your range may change. And then we're going to use the three-point method along with horizontal asymptote. So b to the minus 1 is the reciprocal, 1 over b. B to the 0 power is 1. And b to the first power is going to be b, and so this is the table we're going to use along with your horizontal asymptote y equals 0. And so we're going to use transformations to graph these. So first thing we're going to do is identify the parent, which would be identify the base, and then graph the parent, then use our transformations. So let's go ahead and take a look at the first one here. So we're going to graph f of x equals 2 to the x minus 3 plus 4. So the base there is 2. And so our parent graph is 2 to the x. So we'll make our table x and 2 to the x. Use negative 1, 0, and 1. So it gives you 1 over the base, 1, and the base. Stock form, the horizontal asymptote is y equals to 0. So we'll draw the horizontal asymptote and those 3 points. And then we'll graph that. And to give you a little bit of a reminder of it does have a horizontal asymptote in one direction. If I look at 2 to the minus 10, and that's going to be 1 over 2 to the 10, which is 0.001 approximately. And things are going to get smaller as we get further along towards negative infinity. Okay, so we can go ahead and plot those points. And then we'll use what we know about transformations. So if it's up with the exponent, that's the minus 3 there, that's going to shift it to the right, and we're going to go right 3 units, and then we're going to go up 4 units. Okay. So what happens to the horizontal asymptote if we slide it to the right? That doesn't change it, or sliding it to the left does not change horizontal asymptotes. However, the shift up 4 units will bring that horizontal asymptote up to y equals 4. So we'll go ahead and install our horizontal asymptote. And then each one of our points, we're going to move them right 3 and then up 4. And I put in some extra points there because they were pretty easy to put in. So I put in also 2 squared is 4 and 2 to the third is 8. You don't have to, but those are some extra points there. Okay, so these 3 points here are from me going right 3 and then up 4, right 3 and then up 4, up right 3 and then up 4. Okay. And then I'll go ahead and connect those dots and label my graph. Now if you're doing this on the Lumen homework system or MyOpenMath, then they're going to only ask you for 2 points. So you can still do it by hand. I would highly recommend that you do it by hand using this method, but on the online system they're going to only ask for 2 points. On a test, I will ask for the 3-point method, and I'll have you graph things very similar to what we're doing on the video here. Okay, so we're going to look at a couple more of these, and then we'll get into the logarithms. Okay, this time we have minus 3 raised to the x power minus 2. The base is 3, so that is going to be our parent function of y equals 3 to the x. We'll go ahead and set up our table using minus 1, 0, and 1. 1 over the base, 1 and the base. Stock form has a horizontal asymptote of y equals 0. So we'll put in that asymptote, and then we'll put in those points. I can also put in 3 squared is 9, so that's another easy point that I can put in. Okay, so we'll go ahead and do that. And there's 3 to the x power. Alright, so what's going on with minus 3 to the x power minus 2? The minus outside the function is going to cause a reflection over the x-axis. And if we're reflecting over the x-axis, that horizontal asymptote is still going to be at y equals 0. However, the vertical shift down 2 units is going to cause the horizontal asymptote to go down 2 units. So horizontal asymptote will now be y equals negative 2. So put that in there. Alright, so each one of our points we're going to reflect over the x-axis and then down 2. So here's your reflection and then down 2 on that first point. And then here's our point, reflect it, then down 2. And then this point here would get reflected here and then down 2. Okay, and so then we'll go ahead and connect our dots. There we are, and we'll go ahead and label our graph. Alright, let's go look at another one. This time we have, what is it? We got 5 raised to the negative x plus 4. So our parent graph is 5 to the x power, so we'll go ahead and do our table. Negative 1, 0, 1, 1 over the base, 1, and then the base. Horizontal asymptote in stock form is going to be y equals 0. Put in that horizontal asymptote, pull out those 3 points, and connect your dots, and there's 5 to the x power. Okay, now this one's going to be a little bit tricky. Now if I do negative 1 times x minus 4, and if I distribute that negative sign, that's going to give me negative x and then plus 4. So that's what that exponent is. The negative here, that's going to cause a reflection over the y-axis, and then the x minus 4 is actually going to shift us to the right. So it's a little bit tricky when we have that negative up there with the x. So normally that would be a horizontal shift to the left, but here it's going to be a horizontal shift to the right. And if you imagine if you plug 4 into that function there, you're going to get 5 to the 0, which is 1. So we'll have that point right here. Okay. So let's go ahead and perform those operations. Now when we do the reflection over the y-axis and then the shift to the right 4, that's not going to change our asymptote. So this is negative x to the minus 4, so the negative causes the reflection over the y-axis, and then the x minus 4, that minus 4 is going to cause the shift to the right. Alright, so reflect over the x-axis. I'm sorry, reflect over the y-axis, excuse me. Reflect over the y-axis, and then to the right 4. Horizontal asymptote is still y equals 0. Okay, so that first point will reflect, so it's still there, and then right 4. This point here will reflect it, and then we need to move it right 4. Then finally this point here will reflect it, and then a right 4. And there we are. Okay, so because these are a little tricky, we're going to do another example of this. Oops, sorry. This reflection and then some sort of shift. Okay. So here we have 1/2 raised to the minus x plus 2. So your parent graph is 1/2 to the x. So we'll go ahead and use our 3 points, negative 1. 0 and 1, so 1 over the base, so the reciprocal of 1/2 is 2, 1, and then your base. Stock form has a horizontal asymptote of y is equal to 0, so we'll go ahead and put in our horizontal asymptote and our points, and we can get a couple extra points here, so I plugged in a couple extra points there to get a little bit more of the graph. You don't need to, but it is optional. Okay, so there's our 1/2 to the x. Now if I factor out a negative, that's going to change the sign to make that x minus 2. And so that's going to be the reflection over the y-axis. And then we're going to go to the right 2. Okay, so what makes x minus 2 0 is 2. And so that's going to act like that point here, but it's going to be over here. And then we're going to have that reflection, so we'll have something going on like that. Alright, horizontal asymptote, because we go reflect over the y-axis and then to the right 2, horizontal asymptote is still y equals 0. So go ahead and put that in, and then we'll do some reflections there. And there we go. There is 1/2 to the negative x plus 2. Okay. So now we're going to look at doing the logarithms and what we're going to do is we're going to kind of back our way into it using what we know about inverses. So what we're going to mention here is, since that f of x is equal to b to the x is 1 to 1, because the function is 1 to 1, that means that it has an inverse function. Alright, so it has an inverse function, and so we will call f inverse of x is going to be equal to log base b of x. Log base b of x. So what we'll do is we'll do a compare and contrast between the exponential and the logarithm. Exponential f of x is equal to b to the x. So some stuff about it. B is greater than 0 and b is not 1. That's your base. Your domain is going to be all real numbers. And your range is going to be 0 to infinity. And it's going to have a horizontal asymptote of y equals 0. For your logarithm is going to be f inverse of x is equal to log base b of x. And if you remember it, if you wanted to get from your original function to the inverse, you switch to the x and y. So the base is still going to be the same. Now the domain and range are going to be switched because your x and y's are switched, your inputs and outputs are switched. So now your domain is going to be the range of the exponential, which is 0 to infinity, and the range is going to be the domain of the exponential, which is all real numbers. And in keeping with the theme of switching x and y, the vertical asymptote will now be x equals 0. Okay? Now, if we're going to graph it, what we're going to do is, we already know how to do the exponential table, so we'll go ahead and write down the exponential table. And all we got to do to get the logarithmic table is switch your x and y. So then we'll have 1 over the base and negative 1, 1 and 0, base and 1. Okay, and so that's what we're going to do. We're going to do a couple of examples of graphing some logarithms and also some transformations. And how we're going to do that is, we're going to first identify the base, do the exponential, make the table and all that. We won't actually graph the exponential, but we'll use that to get the logarithm. So here we're going to graph log base 2 of x minus 3. So the base there is 2, so we're going to go ahead and make the table for base 2 to the x power. So negative 1, 0, and 1, 1 half, 1, and 2. Horizontal asymptote of y equals 0. So if we're going to graph the inverse, we're going to switch those x and y pairs. So we get 1 half and minus 1, 1 and 0, 2 and 1. And now we have a vertical asymptote of x equals 0. Okay, and how we achieve this is we switch x and y. So we need to know the table for the exponential, and then switch your x and y for your inverse. So put in the vertical asymptote, and then we'll plot those points. And you can pick some extra points if you want. 4 is 2 squared, and 8 is 2 to the third power. Okay, and there is your parent graph, log base 2 of x. Okay, and your transformations work the exact same way as they do with any other function. So the x minus 3, the minus 3 is inside the function, so that's going to cause us to go right 3, which is going to cause the vertical asymptote to shift 3 units to the right. So the vertical asymptote will be at 3, and then we'll move our 3 points, or however many points you want to use, to the right 3, and we'll label our graph. Okay. So we'll look at, I think, 3 more examples of graphing an exponential, do a couple of different types of transformations along the way. So here we're going to look at log base 1 half of x minus 3. So the base is 1 half, so we're going to look at exponential base 1 half. We looked at that just a moment ago. Do the negative 1 and 2, 0, 1, 1 and 1 half. Horizontal asymptote is going to be y equals 0. Okay, for the logarithm, we'll go ahead and switch our x and y. So we'll have 2 and minus 1, 1 and 0, 1 half and 1, and then we'll switch out the horizontal for vertical asymptote at x equals 0. And again, just as a reminder how we do this, we switch the x's and y's. Okay, so there's your vertical asymptote. We'll plot your points and connect your dots, and there is log 1 half of x. Now we're ready to do the transformation. You have a minus 3, that's outside the log function, because that's going to control up or down. So this is going to be a vertical shift down 3 units. So if we slide that vertical asymptote down 3 units, it's still going to be in the same location. So we're going to go down 3, and the vertical asymptote is still going to be x is equal to 0. Okay, so slide those 3 points down 3 times and label your graph. Okay. And when you're doing these on the homework again, I think they're going to ask for maybe 2, possibly 3. So again, my suggestion is to do it exactly like we're doing. That way you're less likely to make an error. And if you're trying to plug in points into, you can do that for the exponentials, but most calculators don't have a base 1/2. They have a base 10 or they have a base e. And we're going to look at a base 10 right here. So right here I have log base 10 of x minus 5 plus 2. Now if it's base 10, we have a shorthand notation for it. We just call it regular old log. So if we see regular old log, that does mean base 10. Kind of like when we see the square root of x, we really mean the second root of square root of x, but we don't write it. Or if I have x, that could mean 1x the first power over 1. So it's all there, but we usually don't write it in. Similar for this here, it's just the notation there. Okay, so your calculator does have the log, so if you were graphing a log, I guess you could use it, but we want something that works for all of our logarithms. So this is base 10, so we're going to make the table for base 10 for the exponential. Minus 1, 0, and 1, so 1 over 10, 1, and 10. Stock form has a horizontal asymptote of y is equal to 0. And then to get to the log base 10, or just log, we're going to switch our x and y. So 1/10 and minus 1, 1 and 0, 10 and 1. And we have a vertical asymptote of x is equal to 0. Okay, so we'll put in our vertical asymptote of x is equal to 0, and we'll do our best to plot those 3 points and connect your dots. So there is log base 10, or we can call it log of x. Okay, so what sort of transformations are going on here? We're going to go right 5 and up 2. So when we go right 5, that's going to shift our vertical asymptote to the right 5. So we'll have a vertical asymptote of x is equal to 5. We'll put that in there. And then each one of our points. So unfortunately, this is going to be off the graph there, and that's all right. We'll do our best. But the other ones, we're going to move them right 5, and the other being the only other 2 points. We'll move them right 5 and up 2, and then connect your dots. And then we're going to have log of x minus 5 and plus 2. Okay. So I didn't mention that we'll have two special logs. We have log base 10, which we call log, log, and then we have another one, log base e, which we'll call ln. And they have a lot of applications, so we see those on the calculator. ln is probably the best one to use when we're doing a lot of applications. So here we go. We have negative ln of x, which is negative log base e. E is your Euler's button on your calculator. It's about 2.71, and so you have a button on your calculator that's usually the primary function is ln, and then you have the secondary function or the shift or something for e to the x. So you do have an Euler's button on your calculator. It's named after a mathematician called Euler. He did a lot of stuff with the natural number e. Okay, so we'll go ahead and make our table. So put e to the x in, negative 1, 0, and 1. So e to the minus 1 is about 0.4. It's 0.36 something, but for our purposes, it's probably easiest to round to 1 decimal. 0.0 and 1, and a 1 and 2.7. And then horizontal asymptote in stock form is y equals 0. Okay, and then we'll go ahead and put this in, x and the natural log of x, so switch your x's and y's. And then your vertical asymptote of x is equal to 0. Okay, so we'll put that information in, and plot that, and connect your dots. Okay, so there's your natural log of x. And then what's happening with minus log base e of x, or minus natural log, So that negative is going to cause a reflection over the x-axis. And if we're reflecting over the x-axis, our vertical asymptote is going to stay put. So our vertical asymptote is going to be x is equal to 0. And there it is. And so we'll reflect those 3 points and connect their dots. And there's the natural log of x. Okay. So that was a little bit more review of graphing exponentials, and then getting into graphing some logarithms. In the next video, we'll deal more with looking at properties of logarithms and looking at some exponential, maybe some logarithmic equations in the next video. But that's it for now. We'll see you next time.